Well, good morning, everyone. My name is Jesse, and I am with Exploring by the Seat of Your Pants. If you're joining us for the first time, we are all about bringing conservation, adventure, and science into classrooms around the world. And I want to do a special shout out to all our teachers joining live and on YouTube this week as we continue our epic climate change festival. This is program 13 of 23 in 1 week, featuring scientists and explorers from around the globe. We have talked about islands in the South Pacific being inundated by waters of climate change. We've gone up to Svalbard with the ladies at Hearts in the Ice to see what they're doing in their remote Bum Cebu trapper's cabin. It's been a really exciting journey to cover a whole slew of amazing stories from across the globe. I want to do a special shout out to Miss Little, who just joined us in the background as well. Welcome in, Miss Little. Nice to have you guys here. So we're diving in today with another one of our amazing Environment and Climate Change Canada scientists. We are joined live by Josh King, who studies snow. When a lot of people think of climate change, snow and ice is where their mind goes. So he's going to explain a little bit about his work to chart snow conditions around the globe. He's going to talk about his recent expedition to the Northwest Territories, my favorite place I've ever visited in Canada. So I'm really excited to hear from him today. And I do want to share the last line of his bio, his official bio. I almost never do this because it's my favorite of all time. Josh might be one of the few people you meet who loves shoveling his driveway in winter. So we can ask him about that later. I'm very excited. Welcome into Mr. Jansen's class too. And without further ado, Josh, thank you so much for joining us today, and take us away.
Hey, good morning, Jesse. Thanks for having me here today. And that line from my bio is true. I really do enjoy shoveling my driveway in winter.
Fantastic. Come on over. You're welcome all the way.
I get that from a lot of friends. Yeah. So good morning, everybody. My name is Josh King, as Jesse introduced, and I'm just going to share my screen here. So thanks for inviting me into your classrooms today. I'm really excited to talk about snow, ice, and climate change. And we're going to take a bit of a virtual tour through the Canadian Arctic today. So depending on where you're joining from today, snow might be something that you see all the time, or maybe it's something that you've never seen before. But regardless of where you live or where you're joining from today, snow is probably part of your life in some way or another. And that's what I'm going to try and highlight today. But as I'm talking, I want you to think up your best questions about snow and ice. Or better yet, maybe you can tell me something about snow that I don't know, or how it's part of your life. So as Jesse mentioned, my name's Josh, and I'm a snow scientist. I work at Environment and Climate Change Canada. That's part of the federal government of Canada. Now, that's not something that you might hear every day. So people often ask me, what do I study? And when I tell them what I do, I talk about something called the cryosphere. So this might be a new word for you. So let's break it down and talk about what it actually means. The first part of that word, cryo, well, that means cold or freezing. So I work in cold regions. The second part is sphere. Now that might be a word that you've heard from something like, say, your geometry studies. Think of something round, like a ball. But in this case, we're talking about something more specifically like our world or the places in it. So when we combine the two words, we get cold places. And you find out what I study. And the places that I work, well, they're cold, 0 Celsius, below 32 Fahrenheit for up to 9 months of the year. So water stays frozen for a lot of the time, giving me a great opportunity to study both snow and ice. Here's a map of Canada that shows you some of the places that I work, as well as where I live. So I'm speaking to you today from my home in Toronto, Ontario, Canada. But most of my work and the work that our unit does takes place in the Arctic in places like Alert, and you see at the very top of this map, Eureka, as well as Inuvik. And these are all within the Canadian Arctic. And the thing common to those places is that it's really cold in winter. If you look at the map, it uses different colors to show you just how cold it can be in the winter. So the areas that I work, shown in those dark blues, it's below -20 most of the time in the winter. But you also notice that there's parts of the map that are closer, that are in color red. So say like down here in British Columbia, where it's warmer in the winter. Now, that doesn't mean that snow is not important in those areas. So, for example, if you were in British Columbia in the winter, it might be interesting to know that snow is important for things like skiing, so recreation, but it's also an important source of drinking water. Also, other warmer places in Canada during the winter, like, say, the south of Ontario or Quebec, snow is used to do things like generate electricity. So when it melts and it enters rivers, it becomes part of our hydroelectric generation system. So it's important to note that even though I work in cold areas where snow is around a lot of the time, snow is important to a lot of these different places in Canada. So you might be wondering, well, what do these places actually look like in winter? In this picture here, I've just arrived at the weather station that I installed on the left-hand side in a place called Eureka, Nunavut. So it's really cold there, and I'm taking some measurements to make sure that this equipment is working properly. If you look around the picture, just about everywhere you see, there's snow or ice. Now, in the Canadian Arctic, up to 80% of the annual precipitation comes in the form of snow. And that's what gives you this really sort of like white, beautiful landscape that you're looking at. At the time of this picture in particular, I think it was around negative 35 Celsius. And you can tell that the wind is strong too. You can see the snow sort of blowing along the ground. That can make it really hard to keep yourself warm when we're working in these environments. But it's important for us to do this kind of maintenance and install these sensors, because this one, it tells me how deep the snow is throughout the year without me even being there. But in the winter, the Arctic isn't always bad. So in this picture here, we're heading much further north. We've actually landed a plane on ice near the North Pole. The weather's nice, actually. It's calm and it's sunny in this photo. Now, I wouldn't necessarily want to wear a t-shirt when I was doing this work, but with the right clothing, I enjoyed making these measurements in April. Other times of the year, it can be pretty challenging to work just because the sun doesn't even come up. In the picture we're looking at here, you can sort of see my silhouette. There's a little spot of light. That's me wearing a flashlight on my head. So I was collecting snow measurements in January in Nunavut, Northwest Territories in the north of Canada. And at that time of the year in January, we're experiencing something called polar darkness because of the way the Earth's orbit occurs. Now, the sun doesn't actually come up above the horizon because of this for several months of the year. It's not completely dark during the day, but it's dark enough that we have to use flashlights. So you can see in this picture here, I'm using a flashlight to light up where I'm working. It's hard, but it's rewarding work when we're working under these conditions in the winter. Now, scientists like me have been working with snow using satellites for almost 70 years now. And it's important for us to do this work because snow covers about 40% of the Earth. So even though we can't see snow day to day, there's plenty of it around us probably. In the animation, you can see that there's places that we find snow and it changes throughout the year. So in the springtime, we see, or actually in the summer, the snow retreats back to the top of the map, and that's where the Arctic is. And then as the season progresses into the winter, the snow goes further south. And that changes year to year, but we have the same sort of progression every year. Looking at the snow from satellites over really long periods, scientists have noticed two things that we talk about a lot. The first is that our snow in the spring is melting away earlier. So where you might expect to see snow in, say, April, we're seeing less of it. And in general, throughout the Northern Hemisphere, we're just seeing less snow. Now, scientists agree that this is not a good thing and that we as humans are causing this as part of climate change. So let's take a minute now and we'll talk a bit about why snow is important and what its role in climate change is. So have you ever wondered why snow is bright and white? Now, this is because if you were to look at, say you looked out the window and you might have to put on sunglasses because it's so bright. Now, this is because snow is really good at reflecting the sun's energy. You can think of it sort of like sun being sunscreen for the Earth. So when it's around, that energy from the sun gets reflected back into our atmosphere and then eventually back into space. The word that we use to describe that property of snow is called albedo. Now, we say that snow has a high albedo because it's reflecting a lot of the sun's energy. For example, when we get fresh snow on the ground, almost 95% of the energy that comes from the sun gets reflected back into space. So that's why it looks really bright and white to us. But when it's gone or it's not there at all, the Earth takes on a darker color and it absorbs more energy and produces heat that we also feel. So the ground can be described in this case as having a much lower albedo. If you've ever gone outside in, say, the summer and you've put your hand on a hot asphalt road, you felt this effect where the sun has come down onto that dark surface, it's absorbed it, and it's actually generated heat, so you're feeling that hot surface. If we start to think about snow as like a reflective blanket around the Earth, it starts to give us important hints why it's important in the context of climate change. So when it's there, it helps us to keep the Earth cool, but when it's not, the air can get warmer. Now, unfortunately, as the air starts to get warmer, it can melt more snow, and it makes the problem even worse. We call this the snow albedo feedback, and it's an important part of why we're starting to see less snow every year. As the temperatures increases, it makes it harder for that snow to stick around, and as that snow is harder to stick around, then it gets warmer, and this feeds back into itself. Snow is an important part of our climate, as we've just talked about, but it's also really important to animals in the Arctic and pretty much anywhere else you find snow. So my good friend here, the polar bear, is something I met in Churchill, Manitoba in Canada, and they like to build their homes in snow, but they also like to hunt for their food on sea ice. So snow and ice are an important part of their habitat. The animals in the bottom, they're called muskox, and they also live in the Arctic, and they need snow to cover and protect their food in the winter so they can dig down and find it. When we experience changes in snow, it can affect these animals, making it harder for them to survive. And we know that our climate is changing. We're seeing things like more events of rain on snow, as well as the earlier melt that I talked about before. These changes threaten many species by making it harder for them to find places to live, and also harder for them to find food. We as humans also need snow. Most importantly, we need it as a source of fresh water. If you think about snow, it's actually just frozen water, so when it gets warm and it melts, it returns to its liquid form and fills our rivers and lakes, and eventually goes to our oceans. Even in warm places like, say, California, snow is really important in the mountains, where it's used for drinking water and agriculture. In Canada, the snow that melts, we use it for hydroelectric power generation as well, and where it represents almost 60% of our total power generation. In the picture in the bottom, it shows you another way that humans use snow. So we've been using it to get around for a long time. Now, this might be the case where there's no snow and people use snow machines to get around, or maybe you just enjoy cross-country skiing. So we should remember that even though we don't see snow all around us, it's still an important part of our everyday lives. It gives us water to drink, it helps us to grow the food we eat, it's powering our homes, and it can also influence our climate. So it's likely been a part of your life even today, even though if you look out the window, perhaps you don't see it. Now, I mentioned earlier that we use satellites to measure snow and ice. Space agencies that you might have heard of, like NASA, or the Canadian Space Agency, or the Canadian Space Agency, they don't just send people up into space, but they also design satellites to help us to look at the Earth to better understand how our climate is changing. These satellites can be used to measure things like how much snow has fallen, if glaciers are melting, or say how thick the ice that covers the oceans are. These satellites are orbiting around the Earth many, many times per day, so we can collect a lot of information about, say, ice or snow conditions all over the world, but importantly, we don't have to touch it. These satellites are working all the time, so we don't actually have to go to these places. By looking at the measurements over really long time periods, like the 70 years I talked about earlier, we can start to better understand things like climate change and communicate our findings within the government, but also to the public through things like this. So part of my job is to figure out what kind of satellites do we need and to go to the Arctic and test them. So you can see in the animation on the top, me and some of my colleagues are working hard to dig in the snow to better understand it. We're also testing out some new types of measurements to try and figure out how we could use them from space. So my job, I design experiments where we collect information about the snow as satellites that are already in space are going over top of us, or maybe we're taking another system that we've just designed in an airplane, we're using it on the ground. So we often dig down inside of the snow, like the picture on the bottom, to look inside, test new types of measurements that perhaps we could use in the future to launch to space. When we're in the field, we measure things like how deep the snow is or how much water is stored in it. In the video here that you're looking at, that's my friend Peter, and he's using a special probe that records how deep the snow is. So each time he's pushing it down through the snow, he's pressing a button, and when he presses that button, it's recording how deep the snow is and saves the location of where that snow measurement was. Because satellites are covering really large areas, we need really special tools that let us make these measurements fast. So instead of just, say, taking a ruler and pushing it down, this system lets us collect a lot of snow depth measurements really quick over a really large area. It's also important to help us work quickly because it's cold. So this type of information we can collect quickly without getting too cold. Now, if you've ever looked out the window in the winter, you might think, wow, this all looks the same to me. It's just white snow. But as snow scientists, we have special tools like the microscope that I'm holding in this picture that allows us to see things a bit differently. So let's take a look through my microscope, and this is what you might see. When we use these tools, there's details that we can't see with just our eyes. So in the picture, this is what the snow looks like under a microscope. It looks a lot different than what you might say draw when you think of a snowflake that fell from the sky. When that snow comes from the sky and it sits on the ground, it starts to change depending on the environment. We dig into the snow and we look at lots and lots of those samples. Like in the video here, that's what I'm doing. And we try to describe things like what are the shape and the size of the snow crystals. These change depending on where and when we find them. As we dig down, where we see changes, we call those different parts of the snowpack layers. If it's been really cold, sometimes we can get really large snow crystals like you see in the bottom down here. Whoops. Like here in the bottom of the snow. Or if it's been really windy, you might find really small snow crystals like you see at the top here. So when we look outside and we see just a blanket of snow, if you dig down into it, you start to see all different types of things. What we're doing here is called a snow pit, and we use these to start to read snow like a book and understand it by understanding things like how many storms have there been over the winter, or say how windy it's been. Now, I'm not sure how many times I've said this already, but it's really cold working in the Arctic. And in these pictures, you can see from our faces just how cold it is after a hard day of work. As we're breathing and as we're sweating, all that water has to go somewhere, and it starts to freeze to our faces. So in these pictures, you can see me in the bottom right, and then some of my colleagues on the top. All that's freezing onto our faces, and it's cold, but it doesn't actually hurt. It just looks kind of funny. At times, it can be really windy too. So in the video here in the bottom, as it was playing, my colleague Ben and I were trying to dig a snow pit. We put a snow machine behind ourselves to block some of that wind so we didn't get too cold as we were working. To keep warm, we have to dress appropriately. And a lot of the equipment that we actually use is pretty similar to what you might wear, but made of different materials that are better for the extreme cold. One of the important things that we carry is a survival bag. So inside of the bag that my colleague Arvid's here is wearing, we keep a lot of different things to keep us safe if, say, we get stuck out on the snow or ice. Things like food, a sleeping bag, and a heat source. But the other things we take along are what you might wear outside, like snow pants, big gloves, big boots, goggles, hats, and face shields. A lot of people ask me, well, where do you live when you're in the Arctic? When we're up there, we're pretty far from cities, like really far. So there aren't any houses or hotels that we can necessarily stop and stay in. So most of the time we bring our own houses. We live in tents that are built to handle things like wind and cold. We also bring tents that have things like stoves inside of them so that we can stay warm, or we can even cook. Now, the three that you're looking at here, that was from a recent expedition up to the Northwest Territories in 2018. But I didn't have a heater inside of that tent, so when I was sleeping, it wasn't much warmer than the outside, but at least it protected us from the wind. And the one right in the middle, that's my house. With all that snow on the ground, the best way for us to travel along a really long distance on the snow is usually on something called a snow machine, or you might have heard it called a skidoo. We can ride these tracked vehicles on the snow really quickly and help us to get to where we need to go. The yellow things that you see behind, those are really big toboggans. We have a lot of different tools and equipment that we need to take with us. So what we do is we put them inside of those toboggans and we drag them along. The big jackets that you're seeing here help us to stay warm, because as we're driving, of course, the wind in our face can be really, really cold. When things are really far away, like say at the North Pole, we sometimes have to use different things like planes. So what we're looking at right now is the pilot's view of a plane where we're actually going to land on the ice. So this is our pilot's view. You'll notice there's no runway here. You can actually see our shadow of the plane in front of us as we're trying to land. It's important to get out to these places because the measurements are far away, but they're important to our science. I'm thankful here for the skill of our pilots who keep us safe and land on the ice. And you'll see here just in a moment, as the shadow gets closer and closer, we'll touch down and land. Safe on the ice. Now, working in the Arctic, that also means that we have to remember that there's wildlife around us. So here's a picture of a really curious polar bear that we encountered near Churchill, Manitoba, that was trying to find out what we were doing. Now, in this case, we were really quick to move away after taking the picture to a safe distance and make sure we weren't in the way of the bear. While we're working, we often have people designated to just stand and watch out for bears to avoid situations like this. Now, we weren't in any danger because we could go inside a building, but these are situations that we generally like to avoid, and we have to remember that we're within their territory when we're working. We also get a lot of visits from wolves. So here's actually a picture that one of my colleagues took of a howling wolf at a distance from us. And this wolf is, again, letting us know that we're in their territory. But after it did that, it ran off with the rest of its pack, like in the picture in the top here. So even though these encounters might not seem dangerous, when we're working, we're always trying to remember that these are wild animals and we need to respect them while we're working in their habitat. So people often ask, well, I'm interested in getting involved in snow science. What's the best way I can do that? And one of the programs that you can get involved with is through citizen science, through the Knowledge Collective, which is led by Larissa Pizziolato at the University of Toronto. And this is a school-based citizen science initiative that allows classes to get involved with real snow research. So the program's focused on a outdoor curriculum-linked activity where students are introduced to things like data collection and management of snow information. The data collection from the classroom, it allows students to get outside, get involved directly with snow measurements, and then also tie it into very specific curriculum-linked activities. Participation in the program can be weekly between November and May, but it can also be adapted for participation where weekly is not possible. So I encourage the teachers on the call to go ahead and take a look at the website for snowledge.ca for more information on how you can participate in this program and get materials to be involved as well. So thanks for joining me today on our trip around the Canadian Arctic. It was really fun to show you some of the places that we work and talk about why snow is important. If you're interested in learning more about snow and climate change in general, take a look at Canada's Changing Climate Report. And I'll be excited to hear all of your questions now, and hope you can tell me something that you know about snow as well. So thanks for listening.
Josh, that was fantastic. Honestly, I've hosted like 1,000 of these. That was one of the most visually beautiful presentations I've ever watched. So all our classes that are here with us today, that was a real treat. We've got a few groups joining us on YouTube from across Canada and beyond. We've got our 4 live classrooms. So guys, let's dive in with questions. And again, if your students do have comments about snow in their own lives, we'd love to hear those as well. If you're on YouTube, we've already got a bunch of questions. Start sharing in the chat bar. But we are going to begin with a live question to Miss Patriarcha. She is joining us at their grade 4 virtual school here in Canada. If you want to unmute your microphone and kick us off with Josh, come on in.
Hi, Josh. Thank you so much. That was amazing. You have my students engaged.
Oh, did you freeze? I think she froze. I mean, ironically. Oh, you're back. There we go. Thinking about it. This is half the fun, Josh. You have to be a cat on someone's head. This
is the hard part. Can you hear me?
Yes, I can. We're back to hearing you again.
Is it bad that we have less snow every year? This question comes from Logan.
Perfect.
It can be. It depends on where and when you are. The snow that we're seeing changes with, it has to do with that snow albedo feedback, as well as a number of different interactions with climate. In general, it's not great for us to have less snow. The reason being is that it can limit access to things like fresh water, but it also has important implications for our climate. We want to make sure that we're better understanding where and when we are losing that snow. And we're doing a lot of research towards understanding that and understanding what those sort of impacts will be on us and what we as humans will have impacts on the climate as well.
That's a great first question to kick us off. So thank you guys so much for that. A quick note, all our live classes, I know we had a few of you join in after we got underway, so you're all good. I'll come to everyone live in a minute. And Josh, if you can't see us because of your screen share, feel free to exit screen share and you can have a bit of a conversation with us. Miss Delcado's class, right down the street from me here in Toronto, grade 1. It's one of our favorite classes. Come on in, guys, and take it away.
Thanks for the beautiful presentation, Josh. So we have a pretty basic question to start. How is snow made?
So snow starts in our atmosphere, so up in the sky. Basically what has to happen is there has to be what's called a nucleating event. So there's dust or there's small particles that are up in our atmosphere. There's also water. So when it gets cold enough up in the sky and one of those little bits of dust or whatever bumps into some water, they can freeze together. That starts the process of growing a snow crystal. Once that snow crystal grows large enough and it gets heavy, and it falls down. So as it's falling through the sky, that's what you think of when you see something like a snowflake. It falls down, lands on the ground, and then creates the snowpacks that we were talking about today.
I'm so glad we got that question. It was simple, but it's a really important one, so thank you for that. Miss Little's class, they're joining us in Dutton, grade 7-8. If you guys have a question, darting in the background. Hi there.
Hey, hi. Thanks so much for your presentation. We had a lot of questions come in, and actually one that is kind of from a few students here. So Megan and Emma, what inspired you to do what you do? Why did you choose to get into researching snow?
Thanks for that question. I actually grew up in North Bay, Ontario, and there was a lot of snow in my childhood. So everything from skiing to just going ice fishing, digging in the snow. I saw that snow all around me as a kid, and it was a big part of my activities. I even worked at a ski hill for a while as a kid as a ski patroller. I enjoyed those experiences, but I also, as I grew up, I saw that the snow conditions were changing around me, and I wondered why. I got involved in snow research, even starting just working at the ski hill, looking at, back then we were talking about things like avalanches and better understanding how to protect skiers. But as I got older and I got more motivated in school to study snow, I learned about things like climate change and how that might affect my ability to go, say, skiing, or how it was changing my ability to, say, interact with my environment. And so I started to feel very passionately about understanding how snow was changing within my life, but also how it was going to affect other Canadians and people around the world. So I started to look more and more into that. I got involved with some research projects through school that involved snow, and it just really snowballed from there. So it really was a bit of a personal passion for me, where snow was a big part of my life, recognizing that it was changing and then wanting to be part of understanding that change.
That's a fantastic answer. I'm so glad when we get that question. And one thing that we've been talking about this whole week of climate change events is, Josh gets to go to some of the coolest, most amazing places in the world for his work. But I'd encourage all our kids in your classes, ask your parents, ask your teachers how it's different where they are. Wherever you are in Canada, when I was a kid, snowfall was very, very different here in Toronto than it is now. I can tell you 16 and 20 degree days in March, very seldom, if ever, happened. We had snow cover for a much longer period of the year. And so it's one of those rare sciences where you actually can get that anecdotal personal evidence from people in your own lives. And I really would encourage our classes to do that today. Ted, Mr. Jansen's class, I know Luella had a question with you guys, so let's head out to Sarnia. Come on in and go for it. Hi.
Good morning. Well, is my mic on?
Yeah, perfect.
Yeah, I had a question from Luella, and you basically answered the question there, why you chose snow to do research. But we have another question here from Matthew. Has your team or your equipment or you ever been attacked from or by any of the wildlife present there?
So thankfully, we haven't been attacked. We're very proactive in making sure that the wildlife that's around us we're aware of, and perhaps more importantly, that we don't surprise them. So we have people who are constantly looking out and making sure that none of that wildlife is coming into our proximity. Even things like just being sneaking up on a polar bear could be a bad situation. So we're very aware of where the wildlife is around us and take a lot of steps to make sure that we don't get into those situations. So we've never been attacked. We have had equipment damaged by bears. Unfortunately, on some of our meteorological stations, there's a lot of spinning equipment. So when the wind blows, it's spinning a propeller to tell us how fast it is. Bears find that really interesting and they want to come at it. So unfortunately, over time, I think we've lost a few different pieces of equipment just from bears being curious. Maybe they want to rub their back against it to scratch it or sort of bat with their paws at those spinning things. Thankfully, those are things that can be replaced, and we've never had to deal with any issues involving people.
That is a good thing. We've had polar bear questions every single day this week. Again, if you want to check them out, Lisa McCall, Taya Beshoff, we've had amazing polar bear presentations in the past as a nice follow-up for Josh's talk if you're keen. Certainly the YouTube viewers seem to be very excited about polar bears today. I want to take a few YouTube questions, actually, and then we'll do another live round with all our groups. So Miss Gale's class, they're joining us at the Limestone Virtual School, and they want to know the big question: what can we do to help with climate change?
Well, there's a lot of different things that you can get involved with. One of those programs that I talked about earlier, like Snowledge, there's also a couple different other citizen science projects that you can get involved with right now. It doesn't have to be with just snow. There's a whole sort of range of different citizen science projects that you can go home tonight and start to collect data for. That information will help you to better understand how climate change is affecting you or how you are influencing climate change. But it's also going to generate a lot of data that you can then give to a scientist, and scientists can use to better understand it as well. So you're really helping out when you start to be involved with some of these programs where you're collecting data, because you're helping out people like me. I'm only one person, and so I can't go and collect all this data all the time. But as a group, if we start to make decisions to go and understand climate change, collect data, we can have a more positive impact. And then not only are you collecting that data, you're going to become more aware of what climate change is and how you can be a more positive part of that.
I love when we can highlight citizen science. There's so many amazing projects now, and I think a lot of our classes are starting to get involved in these. I mean, earlier this week on Monday, we talked about our own backyard bio initiative. This is coming in May, so lots of neat opportunities to get out there. And I'll highlight some resources at the end where you guys can learn out of the classroom too, which is awesome. All right, Mr. Upton's class, they're grade 10s in Ottawa. They want to know if there's a way to reduce or reverse the snow albedo feedback loop so we don't lose the snow that we are losing that you talked about.
That's interesting. I'm not actually an expert in the areas of, say, geoengineering. There are people that work on those types of questions. I only work in sort of the monitoring and understanding of that process. So I can't give you any specific answers on how we could change it. I do hope in the future that we're able to do things like reduce emissions or make other positive changes towards decreasing temperature trends in Canada and around the world. So any influence that we can have to stop things like, say, the greenhouse effect would have positive influence on allowing us to keep snow around longer. Those are the sort of targets that countries like Canada are trying to go towards to have a positive influence on that situation.
I'm trying to think offhand if any of our speakers this week would speak to that specific issue. I can't think of any, but again, 23 programs in the week. They're all on our website here. And if you subscribe to our YouTube channel, you'll see a whole playlist with all our deep dive into climate change programs. So I'd encourage that for that question. Great, guys. All right, let's go back to our live classes. We're whipping through these, Josh. You're amazing at this. Ms. Patriarca, if you want to come on back in, just unmute that mic and you are good to go.
Can you hear me?
Yeah, we're perfect. For now.
Perfect. Yes. This question is coming from Matthew. What does a typical day look like for you from the time you get up in the morning until the time you go to bed at night?
So our days are extremely busy. I wake up in my sleeping bag. It's pretty cold at that point because we don't have any heaters inside of the tent. So as soon as I unzip my sleeping bag, my day starts because I got to get myself warm. After we get out of there, we go and we make some breakfast. So we usually have like a separate tent for cooking and keeping ourselves warm. We go into that next tent, we start cooking, have a breakfast. We tend to eat things like oatmeal for breakfast, stuff that's easy for us to carry. We just add water to it and cook it really quick. Have a good breakfast. After that, we head outside and we make sure all of our equipment's working. So some of those tools that I showed you earlier, they take a lot of work to keep them running, especially when it's cold. So we make sure that everything's working before we set out. We make sure that we have all of our safety equipment packed with us, make sure that all of our equipment to get us to our site is ready, and then we head out. So at this point, you can imagine I'm wearing everything that I need. So I've got my big jacket, I've got my face mask on, I've got a backpack full of gear, I've already spent quite a bit of energy. So on my way to my site, one of the things I'm doing that might surprise you is I'm eating a chocolate bar. Well, why am I eating a chocolate bar? Because there's a lot of energy in it. I like chocolate bars that have nuts and chocolate in them because that gives me that sort of boost of energy to keep going in the morning. When you're working out in the cold, you're burning a lot of calories, even when you're not moving, because your body's just trying to generate heat. So making sure that we're eating in this process is really important. When we get to the sites, we get to work right away. My job is to do the snow pit work. So I'm taking a shovel and I'm digging in the snow. Depending on where we are, this can just be like 1 minute of work. But if we're, say, up in the mountains, this could be an hour of work to dig 3 meters of snow. While we're trying to do that, you're trying to manage your sweat. One of the problems with working in the Arctic is when it's really cold and you start to sweat, what you saw in the picture of my face earlier where it freezes to your face can happen to your whole body. So if you start to sweat too much, you can get really cold because that's starting to pull energy away from your body. So as we're working, we try to manage things where we're digging or say we're doing heavy lifting. We do it slowly and we make sure that we're doing it without sweating. That's really important. After we finish our sites for the day, we head home. Then we have to do normal things that you would think. We have to cook, we have to clean our areas out and make sure that all of our equipment is dry and safe for the night. We do any repairs that we might need to do. We sit down and we talk about the day. We talk about what we collected, what went well, what didn't. We take all the data that we collected that day and we take it from our written notebooks and we put it into things like computers so that we can make sure we have a long-term record that's safe. After that, we go to bed, hop back into our sleeping bags, zip them up and try to go to sleep as quickly as possible. It's extremely tiring doing this work just because of how cold it is and the amount of things we need to do. So we try to get to bed and make sure we get a good sleep every night.
That was a great, very detailed answer. We get that question a lot. That was awesome. Ms. Delgado's class, come on in and take us away with question number 2.
Thank you. So one question we had was, where does it snow the most in Canada?
That's a good question. I couldn't give you the exact spot off the top of my head, but one place that it does snow a lot are in mountains. So if you think of places like the Canadian Rocky Mountains, that's a place that we would get a lot of snow in Canada. And the reason is because when moisture comes in from the coast, it gets pushed up onto the mountains, it gets very cold all of a sudden. And that causes any moisture that's in the air to fall as snow. When that snow falls, it can be like 3 to 4 meters of snow. This is great for things like skiing. So you're starting to get an idea of why people might go to the Rockies for their vacations. You can do things like skiing in that amount of snow, but because it's falling so often, you also get that really nice fluffy snow that you can ski on. So somewhere along that range might be the location where the most snow falls.
I love the superlative questions from young ones. They're always keen on the biggest, the fastest, the strongest, the most. That's awesome, guys. All right, Miss Little's class, 7-8. If you guys have another question for us, come on in.
We sure do. So it's sort of a twofold question. What is the coldest weather you've been in, and has your body adapted to working in such climates, such cold climates?
I think the coldest that I've ever worked outside was, I think, negative 47 Celsius. And this was working up in Eureka. So sort of very high in the Canadian Arctic. It's extremely challenging to work at these conditions because not only is your body affected by it, but your equipment. I swear there's this magic number at negative 30 where anything that has electronics in it just stops working. It's so frustrating trying to keep things working below that temperature in addition to keeping your body warm. When we're working at that temperature, you might laugh to see us working because I'll work for 5 minutes, then I'll get up and I'll go for a jog. When we're sitting still and your blood's not pumping, your body's natural reaction is to sort of pull the blood away from your extremities. So the first thing to get really cold are your toes and your hands. If you're sitting still for too long, you can get frostbite from that. So I get up and I go for a long jog. We play soccer on the ice sometimes. Anything to just get our blood pumping. Swinging your arms around, doing jumping jacks, you name it. If someone was filming us from afar, I think it looked pretty funny. In terms of my body adapting to the cold, I have noticed something over the years where my hands don't necessarily get as cold as they used to. When I first started doing this, I had a lot of trouble working with my gloves off in really cold temperatures. But in recent years, my body started to adapt to that. It's interesting. I don't actually know the physiological process that contributes to that, but I certainly have a much stronger tolerance for cold now, particularly in my hands.
I love that question. We haven't got that all week so far. One of my favorite stories personally from stories of Antarctic expeditions was that it was so consistently like -40, -50 that when it got down to like -15, people were just stripping off clothes. It was way too hot for them to handle. So neat question, Ms. Little's group. A quick question from YouTube, as we've been getting it a lot, and then I'll wrap up with Mr. Jansen in just a minute. But what kind of food do you bring? People are really keen to know what you're eating out there in the field.
A lot of dried foods. So things like oatmeals, rice, pasta, anything that we can basically melt snow water, boil it, and then create our meal from that. We'll bring like seasoning packets to make things a little more interesting. The food does get boring after a while. You have to sort of balance things between carrying a lot of weight. You also don't want to bring foods that are going to attract wildlife. So you won't find us doing something like a barbecue out there because the smells would bring in the polar bears or the wolves, and that's the last thing we want to do. We bring a lot of things like chips and chocolate bars, high calorie items that let us get in a lot of calories sort of as we're working just to keep ourselves warm. But in the morning, it's definitely porridge with dehydrated fruit in it. Lunchtime, it's, I don't know, maybe a chocolate bar. And then for dinner, it's probably pasta with some sort of seasoning or sauce on it.
One of the unexpected perks of being a scientist, if you're like a kid, you're grade 1 through 4, and you just like love chocolate, is how many scientists talk about the sheer amounts of bad food they eat. It's amazing. By the way, I consider the barbecue just once for like a fantastic photo op. You know, polar bears leering in the background. You got a nice rack of ribs. Just think about it. Mr. Janssens, we'll wrap up with you guys in Sarnia. Come on in and wrap us up.
Yeah, we're wondering how many bars do you get on your cell phone for telecommunications?
So our cell phones most definitely don't work where we are. This is an important question though, because we have to carry tools that allow us to communicate in emergencies. So we have sort of a tiered communication protocol where we carry a number of different technologies. The first one's usually a satellite phone. So this is a cell phone basically that connects to satellites. We also carry, I guess by the brand name, it's something like a spot communicator or an in-reach communicator. It's basically a device that every night we use to check in with our team at home to say we're okay. If they don't get that check-in, then they initiate sort of search and rescue protocols to help find us. The third tier are personal locator beacons. So this is something that's a really simple piece of equipment, basically that you just pop the top off, an antenna flops out, it starts to send out a ping at a certain interval that a satellite picks up. This is sort of the last tier of communications. There's no way for us to tell people what was say wrong or well, it does tell them where we are, but there's no way for us to communicate it through it. It's just a beacon to let people know we are at a certain place and we need help.
I always love that question. It's funny you mentioned the in-reach communicators. We've dealt with people in remote atolls in the Pacific, up in the North, Antarctica. It seems to be a really common thing to have these really relatively high-tech devices to make sure that you can get that little message in. And as you get further and further north and further south, it's harder to actually connect with satellites. We found this from some of our sort of more intensive live broadcasts from the field. So I'm really glad we got that question. So thanks, Mr. Jansen. Josh, this has been amazing. I want to bring up a few quick things for people to keep the learning going. You mentioned at the end of your broadcast, cleanuclimate.ca. I encourage all our classrooms to check that out, as well as Snowledge, however you want to pronounce that, on the screen below. And one really cool program from Environment and Climate Change Canada, climatekids.ca, has got a bunch of amazing resources for kids, especially younger ones. So do check that out when you're done. A lot of great stuff there. Josh, thank you so much for spending some time with us today. This was great.
Yeah, thanks for having me. It was a lot of fun, and all the great questions were really fun to answer as well.
We had some especially great questions today. This was awesome. Well, this marks the halfway point of our climate festival. Again, for everyone who wants to check it out, all our programs are at exploringbytheseat.com. And what we do at the end of every program, as you know, Josh, I'm going to bring in all our teachers to say a big thank you and goodbye. So Miss Patriarca, Miss Delcato, Miss Little, and Mr. Jansen.
Thank you.
So much, guys.